Okay, welcome back. Happy holidays to anybody who celebrated any holidays. We're going to take a look at where we left off on our Match 3 project. So if I hit play in the Unity editor, I've got my project here. If I drag from one area to another, I can detect a match. If I drag from two places that did make a match. If I drag from two places that do not make a match, then it moves back. So this is kind of where we're at. Today we're going to talk about a couple different things. First of all, we want to make sure that when our board generates, it doesn't generate with a match already. And second of all, there's a bit of it's not necessarily a bug, it's just an oversight in programming where if you click anywhere on the board, it automatically thinks you're doing a right swipe. And the reason it does that is because the difference between the X and Y position of your mouse click and your mouse up have no difference, which means that there's 0 between them. And the way that the tangent function works in Unity is it automatically calls that 0 degrees. So there's a little bit of fixing that we have to do. So let's get on this. So the first thing I want to do is I want to open up the board script. Actually, I want to look at the board script and I want to look at the dot script. So let's open up the dot script too while we're at it. Mine's already open, but yours might not be. Okay. Just check and make sure everything's how it's supposed to be. Okay, cool. So, what I want to do here is when the player calculates an angle, or when the program calculates an angle, I want it to detect if there's no difference in between the first and the final mouse positions. So in order to do this, I'm going to create a new variable that I'm going to call swipe resist. So I'm going to go up here into my variables, and near where I have my swipe angle, I'm going to create a new one. I'm going to say public float swipe resist equals 1f. And what that is it's an amount that the calculate angle is going to resist choosing a swipe. You have to have at least 1 unit in any direction in order for it to consider it a swipe. So there we go. Now I'm going to go down into my calculate angle method. So in here, I want to say if final touch position dot y minus first touch position dot y is greater than swipe resist. Now, the problem with this is swipe resist is 0.5, which means that if I end up with something like a negative value, it won't register as being positive or as being greater than swipe resist, which means it won't go left or down. So I need to use either another conditional statement to catch that, or I can use an absolute value function. So absolute value functions are built into Unity. It's capital M mathf dot capital A ABS. And I want to just put my final touch position y minus first touch position y inside of that absolute value function. So I'm checking if the absolute value in between these two, an absolute value, if you forgot from algebra, is just always positive. Well, not always positive, but it's never negative. So if it's a negative number, it makes it positive. If it's a positive number, it stays positive. So there we go. Now I want to also do the same thing for the x position. So I'm going to add a little OR statement at the end here. OR statements are made by these two vertical bars. They're found right above your enter key. And then, because I'm lazy, I'm just going to copy all of this and put it in and change the y's for x's. So final touch position dot x, first touch position dot x. All right. So now I need to open up my braces, and then down here I'm going to close my braces. So it's only going to calculate the angle if the difference between the y's and the difference between the x's is greater than 1, which is where our swipe resist is. So I'm going to save this. I'm going to pop back to Unity here, and we'll hit play. We'll see if this worked out the way it was supposed to. Alright, so just clicking, but then if I swipe, it actually does it. Just clicking, little click, swipe. There we go. So that fixes that issue. Now, as you just saw, sometimes when you hit play, well, most of the times when you hit play, your board will start with matches on it already. This is less than ideal, so let's fix that. What I want to do is go into my board class here, and what I want to do first is to think about how my board is being generated. So we start out with I is 0, and these are the columns, and J is 0, J is the rows. So if we look at our board here, it starts in the 0, 0 position, which is down here. So this one right there. Nope, there we go. It starts in the 0, 0 position, and then it goes to 0, 1, and it kind of works its way up. Get this bigger. So it starts here, goes all the way up, it fills this column, and then moves over to the next column, fills that column, fills this column, fills this column. Now the method we were using to detect matches in the dot class was to choose any specific dot and check to the left and to the right. That's not going to work for this because as we move up, we can't check to the left and we can't check to the right until never, because we're never going to have a row to our right because we're making them from left to right. So, or sorry, a column to our right. So our columns are always going to be just to the left, and also for the up and down, we can't check up because, like, let's say that we're starting out with this dot here, it would have created this column, these four, and then it would be creating this one. So we can't check up from there. We can check down, and we can check left and right, but not up. So what we need to do instead is for each of these dots, check the pieces to the left, 1 and 2 to the left, and then check the pieces down, 1 and 2 down. So as we're generating our pieces, we're going to check, so, and then as soon as we get to a point where we can check 2 down, we're going to check 2 down. As soon as we get to a point where we can check 2 to the left, we're going to check 2 to the left. And we're going to make sure that we're not generating 3 in a row. You can generate 2 in a row, and that would be totally fine. That actually makes the game a bit better because then you have the possibility of having a 5 in a row or a 4 in a row to start out. So it's fine if we get 2 in a row. We just don't want that third one to be there, either from the previous 2 to the left or from the previous 2 down. So in my board class, I'm going to create a new method here. And this new method is going to be something that's going to check whether or not there are matches at that specific spot. And this is going to be instead of being a void, like our setup method was, or any of these methods that we created in the dot class, a void is something that just does something, whereas you can create a method that returns a value. And this is going to be a method that returns something that's either true or false, which is called a Boolean. So we're going to create a private bool, and we'll call this matches at. And okay, so that's the basic part. Why is that red? Oh, whenever you create something that isn't a void, you need to have a return statement in there somewhere. Otherwise, it'll give you an error saying that not all code paths return a value. So down here, I'm just going to say return false down at the bottom. And now that I have a return path, then that's fine. So what I want to do is I want to check if the column is greater than 1, which means that if it's more than the second column, I want to check the column to the left and the column 2 to the left. If the row is greater than 1, meaning if it's the third column, I want to check the row down 1 and the row down 2. So what I'm going to do here is I need to know a couple different values first. So what we've done so far, every method we've created, has just had these parentheses with nothing in them. However, you can pass in a value to make your methods a little more reusable. So in here, rather than just having this be check matches at, I want it to check matches at a specific location. So I'm going to pass in a few values. The first value I'm going to pass in is, we'll call it column and a row. And then I also want to pass in the piece that we're actually checking, which is a game object. And these are called parameters. Now, in the method here, I can use column, row, or piece, and it's fine because those are all variables that are local to this method. However, if I try to call column, piece, or row outside of this method, I won't be able to because these variables are local to this one method. Okay, so I'm going to check if column is greater than 1, and this is the column that the method supplies, and a row is greater than 1, then I want to do something in here. What I want to do first is say if all dots, so I want to check let's check the dots to the left, and then 2 to the left, and then the dots to the down, and then 2 down. So let's say if all dots, column -1, row, dot tag is equal to piece dot tag. So we're checking the tags again to see if there's a match because each game piece has a different tag. So we're checking the piece that is 1 to the left, same row, its tag, if that's equal to our tag, and the piece that's 2 to the left, column -2, row, dot tag is equal to piece dot tag. Okay. Now the next thing that sorry, my cat. The next thing that we need to do is check to see if yep. So if that happens, then we've got a match. So we'll return a true value. And we'll do the same thing kind of with the rows. So I'll take this and I'll paste it down here. Only instead of it being column -1 row, it's going to be column and then row -1. And instead of it being column -2, it's going to be column and then row -2. Okay, and those are going to return true. And then, so if the column is greater than 1 and the row is greater than 1, if it doesn't hit either of these two conditional statements, then it's going to return false, meaning there are no matches at that point. And this is almost good for this logic. However, we need to make a couple changes, but I'll show you what those are in a second. Okay, so this logic is going to be mostly fine. However, we're going to want to make a change in just a minute for a case that'll come up, but we'll cover that in just a second. So up here in my setup method, I'm going to make a few changes. First of all, I'm just going to kind of take a look at how things are being created here. One thing that would be nice is to have the okay, so I'm going to come up here to my setup method and I'm going to make a few changes. First of all, what I want to do is right after here, right after I'm choosing my dot to use, before I instantiate that dot, I want to actually check to see if there are any matches at that place, and if there are matches, then choose a different dot. So the way that I can do that is by taking a look at using something called a while loop. So I'm going to say while matches at, and now here's where I'll pass in my parameters, my values. And my column is I, my row is J, and I'm going to say that my piece is going to be dot to use. Open the brace, hit enter, and that should be fine. Maybe. Matches at. Did I misspell it? Ah, I misspelled it. Okay. There we go. So while this is true, then we're going to choose a new dot to instantiate. So long as there's a match there, we're going to choose a different dot to instantiate, and then we'll instantiate that actual dot. So what I'm going to do here is say dot to use equals random dot range between 0 and dots dot length. Okay, so I'm going to save this. There's a couple issues here. So a while loop is something that we haven't used so far in this project. A while loop just goes through and keeps doing what's in here until the condition is met. So as long as it's true, meaning it's one of these two things, that we have a match at this spot, then it's going to keep choosing a different dot to use. And then as soon as this becomes false, it'll eject itself from the loop, and then we'll actually create the dots. There's a couple issues with this. First of all, you could create what's called an infinite loop, which means that it would just go through here forever, and your program could hang up. And we'll talk about how we can fix that. But for now, let's jump back to Unity really quickly. Actually, I forgot to save my scripts. There we go. Alright, so back to Unity now. Okay. So it's compiling down there. Let's make this bigger. Hit play. Okay, so it created a match down here, and there's a reason it created that match. Let's try it again. You'll see that there are specific situations where it creates matches here. And that's that thing that I said where we have to fix the, okay, no matches. That's awesome. Match on the first column. Match on the second row. So all the matches that are going to be generated now will either be in the first or second column, or the first or second row, or use pieces from the first or second column or the first or second row. And the reason why is in our matches at method, we are only returning true if column is greater than 1, meaning if column is the third column or higher, and the row is greater than 1, meaning if the row is the third row or greater. So in order to fix this, we're going to add a couple new conditional statements in here. So what we're going to do is we're going to say, let's add an else statement. We'll say else if I could spell that would be good. Say else if column is less than or equal to 1, or row is less than or equal to 1. So we're grabbing those edge cases where the column, no spaces between those, where the column is 1 or 0, or the row is 1 or 0. And I'm using an or statement here instead of an and statement like I did up here. Then I want to say if row is greater than 1, meaning our row is greater than 1, which means that we're meeting the first section of this logic, which means that our column is less than or equal to 1. So this is for the first and second column. We want to say if all dots column row minus 1 dot tag is equal to piece dot tag, and all dots column row minus 2 dot tag is equal to piece dot tag. So what we're doing is we're checking the dots beneath us, because in this situation, in this logic, we're in the first or second column, because we would have met the first half of this or statement, not the second half, which means we're looking for if the row is greater than 1, meaning if we're at the third row or higher, we're going to check the row beneath us and the row 2 beneath us, and then we'll return true. And the logic is really similar for if the column is greater than 1. And if the column is greater than 1, that means that we're meeting the second part of this condition. And instead of checking column row minus 1, we're going to do column minus 1 row. And instead of column row minus 2, we're going to do column minus 2 row. So I'm going to save that. Now, the other thing that we need to do to protect ourselves from having an infinite loop is I'm going to throw in a check variable. And this check variable is going to make sure that we don't have it cycling through here infinitely. So this is going to be an integer, and I'm going to call this max iterations. And an iteration is equal to 0. An iteration is however many times it goes through this while loop. So the first time it goes through, that's one iteration. The second time is the second iteration. So I want to check this while there are matches at and max iterations is less than, say, 100. We won't need to have 100 iterations for the most part with what we're doing, but we just want to have it there. The computer can handle it. Also, when we're selecting a new dot to use, we want to say max iterations plus plus. We're just going to increase it by 1. And then when we're outside of here, then we're going to say max iterations is equal to 0. I'm just adding some, in this case, black space, but some white space around this method just so I can understand the logic. Okay, so I'm going to save this, pop back into Unity, and we'll see how this goes. Alright, so if I hit play, oh, alright, cool. So I got a null reference exception. Find matches. Oh, okay. Let's fix that. Okay, so here's what the problem was. If I jump back into Unity and hit play, you can see the null reference exception error. That means that it's trying to access something that we haven't created yet. And the reason that's there is the dot is always looking for matches around it. So we created 1, 2, and this one immediately started looking for matches down and up. And the one that was not that didn't exist would be the dot that's up. So if we look at our dot line 143 and dot line 37, so if we look at dot line 143, it's right here. It's checking to see the dot that's above it, and the dot that's above it doesn't exist. So what we're going to do is we're going to encase this method inside of another conditional statement. It's going to only be active if those dots are null. So we'll say if left dot is not equal to null and right dot 1 is not equal to null, then we'll do everything that's in here. Okay, and then we'll do something similar here. This is called defensive programming to make sure that we're accounting for every situation. So if up.1 is not equal to null and down.1 is not equal to null, then we'll do this. Okay, save my program, or save my scripts. Jump back into Unity, get out of play mode here, let it compile for a second, and then we'll test it again. So I hit play. Oop. Still an error. It's board line 64 this time. Let's take a look. Oh, that's my problem. This needs to be column. So the problem with this was I was checking to see if the row is greater than 1, which means the column is less than 1. Then I'm checking this, and then I still had this row greater than 1 from when I copy and pasted. I forgot to change that. So let's try it now. I'll let it compile for a second, and then hit play. And there we go, no matches. Just to show you guys this max iterations working, I just want to show you something really quickly here. I'm going to add a debug statement, debug.log, max iterations. And if you have, in your console, if you have collapse turned on, this won't be such a big deal. If you don't have collapse turned on, then you're going to get spammed with a bunch of messages, but it'll be fine. So I'll hit play. And it'll tell me how many iterations it had to go through. So, weird. Should tell me a bunch more than just the one. But let's do this again. Okay. Now, the one thing to keep in mind is however many dots you have is going to make it more difficult for the board to generate without making a match. That's why I like to put that max iterations in there whenever I'm doing a while loop. So if I look at the board and I change mine from having 8 tiles to having 4 tiles and hit play, you'll see that there were 5 ones and 1 that was 2. Now, if I change this from 4 to, say, 2 tiles, this is going to be really hard for it to generate without a match. So if I hit play now, you'll see I had a bunch of 100s, 94s, 98s, and even then, after 100 iterations, it still couldn't not make a match, so it still made a match. So I'm going to switch this back to my 8 pieces, and go to my prefabs, and I got dark green, green, indigo, orange, red, salmon, teal, yellow, lock my board. I shouldn't have done that. Alright, I'm going to go back to 0. We'll do all of these except for the tile background. Hey, told you to go back to 0. There we go. There we go. Okay, so if I go back in here, it won't have to do those 90-some iterations in order to not make a match. Okay, cool. So, yeah. Thank you very much for watching. If you have any questions, please feel free to leave any in the comments below. And have a wonderful day.